so today we're going to be talking about 1015 chapter 2.3, analysis of linear functions. We'll just hop right into it. I'm going to be rushing through this a little bit. If you're feeling lost, I recommend going back to the chapter 2.2 graphing linear functions video that I made. I go over some of the methods of how I'm finding the slope of lines a little bit more thoroughly in there, as well as 2.2.1. So if you're confused by some of the process that I'm doing, please go visit those videos. So for this one, it says find the slope of the line shown below. Express your answer as an integer in fraction or lowest terms. Okay, it looks like we have here up 3 over 2. So 3 over 2. That's our slope. Easy peasy. I'm not sure why they have 2 points like that. Maybe they want you to specifically use those. I think it should be exactly the same. Up 8 over 4. Wait, hold on. No, sorry. That's up 9 over 1, 2, 3, 4, 5, 6. Yeah, that'll give you 3 over 2. I like doing the shortest ones, though. This one says, find the slope of the line through the points 7, 0, and 10, 5. We'll use our slope form equation, which is y1 minus y2. So 0 minus 5 over x1 over minus x2, which is 7 minus 10, which will give you negative 5 over negative 3, which will give you positive 5 over 3. That's our slope. That's already simplified as much as it can be. Find the slope of the line through the points, a bunch of gross fractions. So basically we'll do the same thing. 14 over 9 minus 23 over 9 over 13 over 5 minus 23 over 5. And that will give you 23 minus 14. 9, 0. So 9 over 9, which is 1, over, and then 23 minus 13 is equal to 10, which will give you 10 over 5, which is 2. So 1/2 is your slope. Oh, I forgot to mention, both of these are negative, but since they're both negative, it turns into positive. So 1/2 is our slope. Write the equation of the linear function with a slope of 2 over 5 and a y-intercept of 0, 9. So this is easy. F of x, don't forget the f of x, and don't make it 9. It gets angry if you do 9. So 2 over 5, x plus 9. Boom, easy as that. Write the equation of the linear function with a slope of 4 over 9 and a y-intercept of 0, 8. That is same thing. F of x is equal to 4 over 9x plus 8. Find the function that is represented by a line that passes through the point 0, 7 and runs perpendicular to the line representing the function g of x equals a crazy function. Express your answer in the form in slope-intercept form. If you are confused by what I'm doing with this problem, I recommend you go back and watch the video where I talk about, it's called, one second. Okay, yeah, the title is 2.1.2, parallel and perpendicular lines. Yeah, so I recommend you visit that one if you are confused. So we'll take this, we have f of x is equal to, we'll flip this, so we have now 9 over 5. 9 over 5. Minus 2. Oh, wait, hold on. We can't just minus 2. We need to actually plug in. It gives us this point for a reason. So we know it's going to be mx plus b. So y equals mx plus b, which is the same as y equals 9 over 5 x plus b. And we have a point. We don't know if our y-intercept is the same as it is in this equation. In fact, it cannot be, especially if it's perpendicular. So what we need to do is we need to plug in 0 for x, so 9 over 5 times 0. And then plus 7. That gives us plus b equals 7. So that gives us 0 plus b equals 7, which is b equals 7. I forgot to notice that it's a 0, 7, so that's already our y-intercept. However, that would be the process if you had something different for 0 for your x. Sorry, I just had to clear my throat there. Find the equation of a linear function with slope m equals 5 passing through 7, 39. So this one we have to do that other thing. So we know the slope at least is 5. So we'll have, I like doing y just because it's quicker to write. Y equals 5x plus b. Then we can say, okay, 5 times 7 plus b is equal to 39. We're just plugging in what it is for x and y because it's x comma y. We're just replacing things. So that gives us 39 equals 35 plus b. We minus 35 from both sides since we're trying to get b alone. That gives us b equals 4. So then we have f of x equals 5x plus 4. Yes, that would be our equation. Find the least common multiple of the following. And then it gives us a handful of numbers. For this one, there's a nifty-difty trick that I learned in my 950 class. And I hope if you took a 950 class, you also learned this trick. So we have 10 and 4. And what I like to do is I like to take the prime factorization. So 2 and 2 for 4, 2 and 5 for 10. They both share a 2 in common. So we can get rid of this. We have 2 squared. We basically want to find what, hold on, sorry. I'm thinking of least common factor. That's my bad. Basically, we want to say, we can take out this 2, but we still need, oh my goodness. Sorry, I need to get in the right mindset. 1 second. Okay, I was doing weird things, but we basically, we prime factor tree it, so 2 and 5, and then 2 and 2. And we say, okay, this one has 2 2's, and that's the greatest amount of 2's that we have. So we don't need to times, we can just get rid of this one because these 2's take care of that one. And then this one has a 5, and this one doesn't. So what we need to do is 2 times 2 times 5 to get our least common multiple, which is going to give us 4 times 5, which is 20. 20 is our least common multiple. Now, I understand that it was kind of weird and confusing. Basically, well, especially because we didn't include this 2, but these 2 2's cover it. If it's covered, we don't need to worry about it. We just want to do the biggest of both. So then we have 10 and 45, which is, again, 2 and 5. This is going to be 9 and 5, which can be 3 and 3 and 5, and that's our prime factor. So we have a 5 in both, so we'll keep one of those. We don't have a 2 in either, so we'll keep a 2, and we have 2 3's. So it'll be 2 times 5 times 3 times 3. Which is going to give you 10 times 9, which is 90. So 90 is our common multiple. And then 63 and 56. This one's going to give us 9 and 7. I believe, yes, yeah. And then 3 and 3. This one will be 7 and, wait, hold on. I think 7's a multiple, yeah. 5 and 6. Hold on. I know it's a multiple. I think it's 7 and 8. Okay, yeah, it's 7 and 8. So 7, 8, that gives us 2 and 4, which is 2 and 2. Boom. Okay, so we have 3 2's here. We need to keep our 3 2's. 2 times 2 times 2. We have 2 3's here. We need to keep these 3's. 3. We only have 1 7, so we don't need to include both. And then so times 7. And that will give us 8 times 9 times 7, which when I plug that into my calculator, because I'm not very happy to do it in my head or by 9, we get 8 times 9 times 7. That would be 504. Yep. Yeah. Add or subtract the following fractions. Express your answers as fractions in the lowest terms. The reason why we just did that common multiple stuff is because we need common denominators here, and that is the only thing, that's the technique that will help us. So 6, which is 2 and 3, and we have 10, which is 2 and 5, so we have 2 times 3 times 5 as our lowest common multiple, which looks like it will be 30. So we have 30. 30 is our common denominator. So what can we times to 1 over 6 to get this denominator to equal 30? We can times 5. 5 over 5. And we need to times by 5 over 5 because that means we're timesing by 1. And we're allowed to do that because timesing anything by 1 doesn't change the value. So that will give us 5 over 30. And that is plus 3 over 30, because we can times 3 by 1/10 to get 3 over 30. 3 over 3, I mean. So then that will give us 8 over 30. That can be reduced further to, we can divide that by 2, which gives us 4 over 15. That's our lowest one. So then we have 7 over 5 and 1 over 7. And we're adding. Same principle. 5 and 7 are both prime, so we need them to do 5 times 7, which is 35. We can times this by 7 over 7 to get the denominator to be 35. So 7 over 7. And that will give us, that will give us 49 over 35. And then we can times this by 5 over 5. Which will give us plus 5 over 35. So that will give us 54 over 35. And I believe that does not reduce further. I'm taking your word for that one. I'm taking my word for that one. Yes. Okay, so then we have, I don't know if I will go through all of these because it's just a lot of the same thing over and over and again. If you're having problems, well, I'll do one very more in depth. So we have 3 over 7 plus 3 over 10. We need to find the common multiple. So 7 and 10. 7 is prime. 10 is 2 and 5. So we need 7 times 2 times 5, which is going to be 70. 70 is our lowest common multiple. So we can times this by 10 over 10, which is the same as 1. So the value is not changing, to have the denominator be equal to 70. So we have 30 over 70. And then we can times this by 7 over 7 to get the denominator to equal 70. 3 times 7 is 21 over 70. That will give you 30 plus 21, which is 51 over 70. That is your answer to that problem. This one is asking you to multiply or divide. We can just go straight across. Another thing that we can do is cross multiply. So if you prefer to learn a new method, just keep watching. If you want to just do a cross and then do your process of dividing to get the lowest terms, do that. It's fine either way. Over 5 over 14. But what you can do is you can try cross multiplying and say, okay, 5 goes into 25 5 times. So this turns into a 1 and this turns into a 5. And then 6 goes into 14. It doesn't. But both are divided by 2. Can be divided by 2. And that will give us 3 and 7. So we'll have 3 over 5 times 7, which is 35. That's our lowest term thing. So 3 over 35. 5 over 8 times 7 over 6. We can cross multiply. 5 and 6 can't go together, and 7 and 8 can't. So we just do multiply straight across. So 35 over 8 times 6, which I think is, I always am bad at my 6's and stuff. 36, 42, 48. My bad. Okay, this is our fraction. We can cross multiply here. They both are divisible by 5, so we get 4 and 9. And then these are both divisible by 3, so we get 4 and 6. They actually both are divisible by 6, so let's do that instead. So 2 and 3. 4 times 2, and then 3 times 9. 4 times 2 is 8. 3 times 9 is 27. This one, when we're dividing, we need to copy that flip. So we keep this one, 5 over 22, and then we're dividing by 5 over 12, negative 5 over 12. But when we can multiply and just flip to the reciprocal. So we get 12 times, negative 12 over 5 instead. And then we can cross multiply. 5 goes into 5 one time, so these both turn into 1. 12 goes into, it doesn't go into 22, but they both are divisible by 2. That gives you 11 and 6. 1 times 6 is 6. 11 times 1 is 11. 6 over 11 is your answer for that. 9, and then you can copy that flip again. 9 over 7 times 54 over 42. And boom, boom. I don't think 7 goes into 54. 49, nope. And 9 does not go into 42 either. So I believe that this is going to be our Does 3 go into 42? Yes, 3 does go into 42. So we can change this to 3 over 7 times 54 still. Over, and then 42 divided by 3. 3. Oh, wait, whoops. 3. 1. 3. Wait a minute. That's 42. My bad. I'm getting lost. Sorry, I've been making math videos all day. So then that would be 12. 4. So 14. 14 times 3 would equal 42. So now we can multiply straight across. I'm not going to do that because I don't want to do that right now. And then whatever that is. And then you can do it with your calculator though. And then yeah, so hopefully you get the idea. I'm not going to finish it because they take a long time to actually solve and do it. And I think that we've done enough examples. If you are still having questions and problems, please let me know. And I will answer as soon as possible. And yeah, have a good one.